Hello. Uh, let's evaluate this integral I equal to 0 to 1 x square by 1 minus x ln of x into dx. Right. Here, as you can see, in the denominator, it's 1 minus x. Right. This is 1 by 1 minus x, which is equal to 1 minus x whole power minus 1. When you expand this as series, it will be 1 plus x square plus and so on, which we can write it in the form of summation, right? Summation n equal to 0 to infinity x power n. Let's substitute this in I. That implies I equal to integral 0 to 1 x square into summation n equal to 0 to infinity x power n ln x dx, right? Then I equal to, bring this summation out, summation n equal to 0 to infinity integral 0 to 1 x power n plus 2 ln x dx, right? This we can do by integration by parts. Let us consider this as u and this as v dash. Then what we can do is, here it is I equal to summation n equal to 0 to infinity, right? This will be uv, right? V will be x power n plus 3 by n plus 3 ln x. This will be from 0 to 1. And the next one will be minus of integral 0 to 1 u dash into v. Then it means x power n plus 3 by n plus 3 into 1 by x. Let's consider this as a part and this as b part, right? Uh, Calculate part a first. Let's see what happens here. If you substitute this limit x power n plus 3 by n plus 3 ln x 0 to 1, if it's x equal to 1, if ln of 1 will be 0, if x equal to 0, this will be 0. That means this term will not contribute. That means I equal to summation n equal to 0 to infinity minus integral 0 to 1 x power n plus 3 by x into n plus 3 dx, right? Which can be written as I equal to minus of this n plus 3 is constant, right? We can uh, summation n equal to 0 to infinity, because it's constant we can move it out, n plus 3, then this will be 0 to 1 x power n plus 3 minus 1 to be 2 dx, right? This will be I equal to minus summation n equal to 0 to infinity 1 by n plus 3, then this will be x power n plus 3 by n plus 3, integral limits are 0 to 1, which will give rise to I equal to minus summation n equal to 0 to infinity 1 by n plus 3 whole square into 1 minus 0, which is equal to minus summation n equal to 0 to infinity 1 by n plus 3 whole square, which is I. Let's substitute the values of I. and see how does it look like. So if n equal to 0, it will be look like minus 1 by 3 square. If it's 1, it will be minus 1 by 4 square. Then it goes on. Let's take minus as common here. Then it will be 1 by 3 square plus 1 by 4 square plus 1 by 5 square and so on. It looks like a pattern, right? The Riemann zeta function of 2. So let's do one thing here. Let's add this 1 by 1 square plus 1 by 2 square plus 1 by 3 square and plus so on, and subtract that other terms, then minus 1 by 1 square minus 1 by 2 square, right? Then this value will be I equal to minus of, this is the Riemann zeta function of 2. This will be minus 1 by 4 minus 1. This will be minus 5 by 4. Then this will be 5 by 4 minus Riemann zeta function of 2. As we know that Riemann zeta function of 2 equal to 1 by 1 square plus 1 by 2 square plus 1 by 3 square equal to plus and so on equal to pi square by 6, which I derived it in my previous videos. You can see once. That means I value will be 5 by 4 minus pi square by 6, which is equal to integral 0 to 1 x square by 1 minus x ln x dx equal to 5 by 4 minus pi square by 6. This is the desired result.